look at the graphs. Today we're in chapter 4, and this chapter is allocated to graphing the 6 trig functions: sine, cosine, tangent, cotangent, cosecant, and secant. And so there's a lot we're going to cover today. Part of it is review from the last class period on drawing the sine and cosine graphs, and then from those we're going to build off of them to get the others. Keep in mind that in this chapter I will not be teaching the same way as the way the book is laid out. I will be teaching it a different way, and what you need to know is you have to memorize the sine graph, the cosine graph, and the tangent graph, and then it's going to be all about reflections, about asymptotes, and knowing reciprocal functions. So by looking at the sine graph, you're going to remember on the sine graph that from the table, it's going to start at 0, 0 and go up to 1 and come back down, and the period is going to be 2 pi units. So it's going to have one cycle through 0 to 2 pi, and what you have to remember on the sine graph is start at 0 and go up. Start at 0 and go up. On the cosine graph, you're going to start at 1 and go down. And again, it's from 0 to 2 pi, so that completes one complete cycle. When you draw these, draw in the boundaries first. So put in the angles, put in your 1, -1, and then put the main dots in such that it gives you specifics on where to draw that curve, and then your curve will look a little bit better than if you did it one point at a time. Okay, so that's the sine and the cosine very quickly. We're going to go back to the table, and on this table, we're going to fill in the tangent x. Before your sine x and cosine x were filled in, and you graph those two graphs, and I just did a quick summary on that. But if you go to the tangent graph, you're going to see that the angles are going to be in multiples of pi over 4. So from your table, tangent of pi over 4 is equal to 1. And then the tangent of pi over 2, tangent of pi over 2 really is sine over cosine. And so that really becomes sine of pi over 2 is 1, cosine pi over 2 is 0, 1 over 0 is undefined. So that makes this undefined. Not 0. 0 is a number. Undefined is a concept. It does not exist. 3 pi over 4. Tangent 3 pi over 4. It's in the second quadrant. That's going to be a -1. Tangent of pi is going to be equal to 0. Tangent 5 pi over 4, that's in the third quadrant. That becomes +1. Tangent 3 pi over 2 is undefined again, -1 and 0. You can kind of see that there's a pattern there as you fill out those numbers and you go along. What we're going to do next is going to be to draw the tangent graph and the cotangent graph, and then the cosecant and the secant, and then we're going to talk about amplitude, period, domain, and range for all 4 of those. So when I go and graph the tangent graph, what I have to remember is the asymptotes. Now, when you remember tangent, the ratio identity is sine x over cosine x. That's important because at sine x over cosine x, it's undefined where cosine x equals 0. So if I remember where my cosine x equals 0, it's where this is undefined, and that's where I'm going to draw my asymptotes on the graph. Like I want to specify where my asymptotes are. So if I'm looking at the cosine graph, right here, you're going to see that your zeros are going to be at pi over 2, 3 pi over 2, negative pi over 2, and it's going to continue that way. That means at pi over 2, we're going to draw in a dashed line, which is the asymptote. 3 pi over 2, negative pi over 2. Asymptotes are not part of the graph. Dashed lines are like they're invisible. Now, the point off of the table that we're now going to look at is the tangent of 0 is actually 0. So I know that that's 1 point on my graph. The next point on the graph is going to be pi over 4. Tangent pi over 4 is equal to 1. That's going to be another point on the graph. I could also know that the tangent of negative pi over 4 is the same thing as tangent 7 pi over 4. And that's going to equal a negative 1/2, negative 1. And so you have those 3 points, and I want you to think about this a little bit abstractly, but when you see the cosine of x is on the bottom of the tangent x ratio, as the cosine x actually gets closer to 0 here, that means that the whole number is going to get closer to a very, very large number, or it's going to approach infinity. Again, as cosine goes to 0, tangent x is going to go towards positive infinity. That means that if I go back here to this graph again, I'm looking at the cosine graph, as it goes closer to pi over 2, it's getting closer and closer to 0. As it goes to pi over 2, the cosine x is going closer and closer to 0, which means the tangent graph is going to go closer and closer to positive infinity. It's going to go towards positive infinity. So that means that this graph actually is going to come up like this, and on the other side of it, it's going to get closer and closer to 0, but approaching it from the negative direction means you're going to approach, tangent x is going to approach negative infinity. The smaller the denominator, the bigger the number, right? If you think about that, the smaller the number on the bottom, if you think about 10, 100, 1,000, if you divide by 1,000, it's the same thing as multiplying by 1 over 1,000 over 1. Let me say that again. Yeah, if you have 1,000 on the bottom, okay, that's pretty large. That means the whole thing's going to be pretty small. Okay. If you go to like 10, that number becomes bigger. If you go to 1, this number is going to be bigger. If you go to 0.1, bigger yet. 0.00001, bigger yet. So if the bottom was 1 over a million, you're going to multiply by a million over 1 type of idea. That's why this goes to infinity as the cosine x goes to 0. Okay, I spent enough time on that. At this point, this pattern is going to continue with your tangent x. So it's going to look like this, not intersecting the asymptotes, but approaching them. Same concept for the cotangent x. So again, we're going to think about cotangent x is the cosine x over the sine x. Where does the sine x equal 0? I know where it equals 0 because it's going to be starting at 0 going up. So it's going to be at pi going to be at 2 pi. Those are going to be your asymptotes for the cotangent x, because that's where this fraction is undefined. Then it's a matter of drawing it in at pi over 2. It's going to be at 0. And you know that it's going to go like this, and I'm going to explain why that's true. And again, it's the same exact pattern. It's a cycle. And it's going to continue to the left and to the right, to infinity. Now, one other thing that I want to do as a comparison between these two is this. Notice from Santa Claus that this refers to angles going from 0 all the way in that direction, right? It's going from 0 all the way to 2 pi. This Santa Claus is not the same axis as these. This strictly is looking at angles. This is graphing angles versus values. It's different. But what's in common is that this is angles and these are angles on the axis. So if I'm thinking about tangent now, I know the tangent x is going to be positive from 0 to pi over 2. Well, are your values positive from 0 to pi over 2? Yes, they are in this graph. What about the second, from pi over 2 to pi? Are they negative? They're supposed to be. Yes, they are. They are negative. Yeah, pi over 2 to pi, I mean. Pi over 2 to pi, going from pi over 2 to pi. This should be, that was a mistake there. This should be pi units. No. Yes, that is pi. Yes, that is pi. So from pi over 2 to pi, it should be negative, which is in the second quadrant. Third quadrant, pi to 3 pi over 2. Pi to 3 pi over 2 should be positive. It is positive in that quadrant as well. So this falls in line with Santa Claus when you just think about the angle. Same thing here. Cotangent from 0 to pi over 2 is actually positive. Second quadrant, pi over 2 to pi, negative. Third quadrant, positive. Fourth quadrant, negative. This is a little bit easier to see because it's lining up pretty nicely. All you have to do on these, get your asymptotes down and then think about where it's positive or negative from the angles. Let's go to the second two graphs. You have the cosecant of x and the secant of x. We put down a framework of dashed lines. Those are not part of the graph. Same idea. We want to put asymptotes down first. Where is the sine x equal to 0? Sine x is equal to 0 right at the y-axis and at pi and at 2 pi. The key to these is just drawing in your asymptotes and then drawing in the rest of the curve. Now, same concept as before. That is, as the sine x goes to 0, this is going to go up toward positive infinity. Meaning, as this goes to 0, the real graph is going to go toward positive infinity. And so you're going to see that that's going to go up like this, and that's going to go up like that. As this comes down to 0, this is going to be a reciprocal idea where it's going to go to infinity. Same thing on the negative. Approaching 0 from the negative side, on the bottom, it's going to be like negative 0.0001. When you divide by that, it's going to be a very large small number. Or a very large negative number, I should say. And that's going to continue. So the graph really is the black in between. Also notice that 1 is included and -1 is included, because if you were to put pi over 2 in for sine x, you're going to get 1. 1 over 1 is 1, so we know that that is part of that graph. Same idea for the secant x. You're going to draw in your asymptotes. Hopefully you're seeing a pattern here. As soon as you get your asymptotes in, then you can go ahead and draw those parabolas. Now, the last thing that I want to do is cover domain, range, amplitude, and period for each of these graphs. Domain, range, amplitude, and period for these graphs. So we'll write those in. And luckily, there is some overlap between the two. Some overlap. First of all, for the tangent x, let's do the period. The period for both the tangent x and the cotangent x is going to be, where it completes one cycle, easy to see on the cotangent x, it's going to be pi units. So I know that the period is pi, because then it repeats. That's different. Notice, sine and cosine, it was 2 pi. This is just pi. The amplitude is the max minus the min divided by 2, or halfway from the middle to the top of the graph. Well, on this graph, you're going to see there is no max, there is no minimum, so you can't have an amplitude. It does not exist. Please do not put down 0, because that's a lot different. It does not exist. The range on both of them is going to be all real numbers. So you could write it like this, with parentheses on the end, or you could write it like this, all real numbers. The domain is different, however. The domain, you're looking at your x's. When you're looking at your x's, you're thinking, okay, what are my possible x's? Well, that becomes a little bit harder because you have all those asymptotes. So let's see if we can make sense of this. I'll put the domains over here because they're not going to be the same. Domain is going to be all real numbers. X does not equal, and it's supposed to not equal, let's see, -1/2 pi, -1/2 pi, but yeah, +1/2 pi, +3 pi over 2, +5 pi over 2. So if I could write that, it could be, let's see, 1/2 pi times k, and 1, 2, that doesn't work, does it? If I put 0 in for k, I get 0. That does not work. So let me just redo this. Thought I could write that as a little bit of a shortcut. Just to be on the safe side, x does not equal -pi over 2, +pi over 2, +3 pi over 2, etc. I think I can rewrite that and say, or you could say it doesn't equal pi over 2 plus pi k, and I think that would take care of it. Now, if you put in 0, 1, 2, -1, 2, it'll work. It'll cover all those. So either way, you could write that down. Going back to this one, the cotangent. The domain. Domain will be all real numbers. X does not equal, well, this is just going to be 0, pi, 2 pi. So it'll just be k times pi. Or you could write it the other way. Last two going through all four again, and then we're done. Do it the same exact way, period. On both of them, the period, one complete period of the pattern is going to go from 0 to 2 pi. So your period is back to 2 pi. Same as sine and cosine, right? The amplitude is going to be max minus min divided by 2, which is going to be, actually does not exist because there is no max, there is no min. The range on both of them is the same. That's your y values. Which are your y values that are covered? They're going to be all y's, and it's going to go from y's greater than or equal to positive 1 and less than or equal to negative 1. So it's y's that include 1 and higher and negative 1 and lower. And that's for both of them. The only thing that's different is going to be the domain. So we'll go back over here. The domain is going to be, let's see, all real numbers, x's. And now I can't include my asymptotes, so it's going to be 0, pi, 2 pi. That means it's going to be x cannot equal pi times k. Right, 0, 1, 2, 3, put that in and you'll get your asymptotes. And on this one, x, all real numbers, x cannot equal, well, that's where I'm hitting pi over 2. So let's start with pi over 2 and add, we're actually adding a period onto that, pi k. What do you have to know going forward? You have to make sure that you memorize the sine graph, the cosine graph. From there, you can develop the cosecant of x and the secant of x. You also have to know the tangent graph. Know the tangent graph is between negative pi over 2 and positive pi over 2, and think about the quadrants. It's going to go up from 0 to pi over 2. Cotangent, think about the asymptotes, it's 0 to pi. It's going to go positive in the first quadrant from 0 to pi over 2. Once you know those, we're going to start reflecting and moving and on all 6 of them, so it's going to get a little bit confusing. And shrinking and stretching. So this is the basics for the whole chapter. You definitely